From time to time, astronomers need optical assistance, and conveniently, unique effects occur in the vastness of space that open up a direct insight into remote, actually invisible structures, ones that Albert Einstein predicted almost 90 years ago. At the same time, the structures detected with the help of the gravitational lensing effect also remind us, once again, that equally gigantic and enigmatic colossi lie dormant out there. On the one hand, black holes like T618 and Phoenix A, with their tens of billions or even trillions of solar masses, defy all known laws. On the other hand, they shouldn't actually exist at all in this form. Even Albert Einstein was not infallible. Quite the opposite, in fact. The creator of the theory of relativity was once so convinced of a rigid and unchanging universe that he added a cosmological constant to his equations, a step he later regretted, allegedly calling it the greatest folly of his life. Today, however, we not only know that the universe has been expanding continuously since its creation 13.8 billion years ago, but also that Einstein was all the more ahead of his time in other respects. As early as 1936, the physics luminary speculated in an article in the journal Science that a collection of high masses could deflect the light of objects behind them like a lens, and, in this way, create several images of one and the same structure. However, the so-called Einstein ring that is created requires a very special constellation, namely that the background source, the lens, and the observer are exactly in line. Only then will the astronomical motif be distorted into a characteristically round shape. At the same time, Einstein was not exactly optimistic that his theoretical prediction would ever be confirmed by real observations. He wrote, "Of course, there is no hope of observing this phenomenon directly." In the meantime, however, we know that Einstein's pessimism was ultimately not borne out by reality. In 1988, radio astronomers used the Very Large Array to detect exactly the structure that the visionary had predicted a good 50 years earlier. Basically, it is a ring of electromagnetic radiation that, as already mentioned, is created by the gravitational lensing effect. This, in turn, is based on the gravity of massive objects, such as galaxies, which bends and amplifies the light of objects behind them. And although this effect is by no means always accompanied by spectacularly distorted multiple images, it has turned out to be an outstanding tool for astronomical research. The cosmic lens sometimes makes galaxies, stars, and quasars visible that would otherwise appear completely invisible. Of course, the sensational first discovery in 1988 was no isolated case. Experts are now tracking down Einstein rings very frequently, as well as other structures such as Einstein horseshoes, which are not fully closed, or completely different spectacular motifs, such as the Einstein cross. This is a quasar 8 billion light-years away. In other words, an active galactic nucleus which, as seen from Earth, lies exactly behind the center of a galaxy 400 million light-years away that acts as a gravitational lens. Due to this lens, for similarly bright objects finally appear in an approximate cross shape, with the galaxy core at the center. The fact that the gravitational lensing effect not only creates cosmic crosses, but also sometimes brings big surprises to light was demonstrated to researchers again in March 2023. At that time, they managed to identify one of the largest black holes in the entire universe. How the experts discovered one of the largest black holes in the cosmos. Although black holes are often regarded as cosmic destruction machines that literally swallow up everything without fail, it is now considered certain that practically every galaxy center is adorned by such a supermassive gravity monster. In fact, inactive black holes can behave like normal mass bodies outside of their event horizon and can be orbited by other celestial bodies on stable orbits without any problems. Furthermore, experts assume that these bizarre monsters play a fundamental role in the development of galaxies. And of course, our Milky Way is no exception. Named Sagittarius A star, the central black hole of our home galaxy weighs in at around 4 million solar masses and is therefore no more than a lightweight compared to its cosmic counterparts. In fact, there are numerous black holes out there that weigh billions of times more than the Sun. 2 years ago, astronomers caught one of them. But before that happened, The experts had first become aware of an unusual property of the central galaxy in the AEL 121 cluster, which is about 2.7 billion light-years away. As soon as it passes in front of a background object, its gravitational lensing effect is significantly stronger than the visible size, the number of stars, and the dark matter of the structure would suggest. Studies have shown that the affected galaxy, AEL 121 BCG, deflects the light of distant background objects by almost 2,000 light-years and forms a distorted arc. A few years ago, researchers also identified another smaller arc located opposite the first, and its position and shape suggest the existence of a huge mass at the center of the galaxy. The suspicion that this could be an inactive black hole was obvious from the start. To further test this suspicion, astronomers led by James Nightingale of Durham University evaluated new images of AEL 121 BCG and its gravitational lensing effect from the Hubble telescope. In the first step, they used an astronomical simulation on supercomputers to determine what kind of supermassive black hole could be responsible for the deviations recorded. The result was surprising. According to the evaluations, it was clear that there must be a mass monster at the heart of the galaxy, weighing in at a whopping 33 billion solar masses. Just to be clear, with this incredible mass, the object is already scratching at the theoretically predicted upper mass limit for black holes. But that's not all. The giant is also the first black hole ever to be added to the star maps using the gravitational lensing effect and additional modeling. The fact that the Colossus has eluded researchers' gaze for so long is due to the fact that, as mentioned, it is inactive. While active black holes incessantly devour matter and are easily detected by the energy released in the form of light, X-rays, and other radiation, their inactive counterparts remain invisible. However, a fundamental question is much more obvious. Why are there much heavier black holes out there than the one just presented? Why T618 and Phoenix A are so problematic? To understand what this is all about, we should first address the question of how heavy black holes can actually get. Well, if British astronomer Andrew King is correct, the answer is around 50 billion solar masses. More specifically, King used astrophysical models to conclude that the glowing disk of gas surrounding a gravitational monster and constantly supplying it with matter becomes unstable and collapses at a certain size. However, this upper limit only applies to the maximum mass that black holes can accrete on their own. Beyond that, it's also possible for two giants that are already at this limit to merge, creating a black hole of up to 270 billion solar masses. However, King explains that the resulting object would explicitly not have a gas disk with a characteristic radiation. Now, we can also understand why the existence of T618 seems so mysterious. After all, it does have such an accretion disk, and at the same time, weighs an incredible 66 to 70 billion solar masses. Even more impressive is Phoenix A, which lies in the Phoenix cluster 8.5 billion light-years away. According to the latest calculations, it has 100 billion solar masses. And while the upper mass limit postulated by Andrew King has its problems, some scientists believe that there could be black holes with up to 100 trillion solar masses. And with that, our vague hope is that you'll hit the subscribe button. We'd love for you to subscribe so you never miss a new video from us again. We'll see you soon.